Hi, I'm John Hall at TriMech, and today we're going to take a look at Solidworks Mbd. In today's world, we traditionally have both 3D CAD files and 2D drawings associated to those CAD files being sent to manufacturing, production, and development. Drawing creation and maintaining drawings can be a very time-consuming process, and spending engineering time and money to create and maintain these drawings can be very costly. Some of the time, the design changes aren't even captured on the drawings, and they don't match the 3D models. With most files today being manufactured with CAM and CNC directly on the 3D model, the drawing, for all intents and purposes, is kind of an afterthought. So let's take a look at Mbd. Solidworks Mbd was developed to eliminate the overhead of having to maintain both CAD models and drawings in the same system. Solidworks Mbd stands for Model-Based Definition, and it allows you to publish out technical data packages, or TDPs, for drawingless manufacturing solutions. It allows you to define, organize, and publish all of the 3D product and manufacturing information directly inside the 3D model and push this out to industry standard file formats like PDFs and e-drawings, as well as step files. This really allows you to create documents that conform to any sort of standard for downstream PMI, such as MIL Standard 31000A, ASME 1441, and other standards like DIN and ISO. So let's take a look inside Solidworks Mbd. Here you can see we have a PDF with all of the dimensional information needed to manufacture this part component. This part component is a gear plate for an assembly and has a lot of different tolerancing and dimensional information that need to be conveyed to manufacturing downstream. All traditional views like top, front, right, ISO are all captured directly in the PDF, as well as dimensional and tolerance information, which is actually attached to the model itself. So as I select a dimension, for instance, it will highlight exactly what that dimension pertains to and give me a lot more information about each dimension and tolerance than a traditional drawing actually would. You can also capture information from assemblies, so if you want to capture bill of materials as well as cutaways, dimensional information, and even explode views, that can all be implemented into a 3D PDF as well. So within SolidWorks itself, you can also see that all that information is getting captured at this level as well. So the 3D views are just another tab inside of SolidWorks where you can see the front, the top, the right, and any sort of other detail information that you need for manufacturing is captured directly within the SolidWorks model. And there's no need to have a drawing associated with this to understand very easily the dimensions and tolerances needed for manufacturing downstream. So that's just some of the content that you can generate from Mbd. So let's take a look at how that's done from within SolidWorks itself. So what we're going to take a look at here is how to generate out your views and your 3D dimensions. Then we're going to take a look at some of the export capability and what you can actually push out downstream from within SolidWorks. And finally, we'll take a look at how the standards and templates are developed so that you can ensure you have your own company standard like you traditionally would on a 2D drawing. What we're going to take a look at here is the same gear plate that we were working with before for this underwater camera, and we're going to create a couple of different views for this as well as some dimensions on those views. So inside of SolidWorks itself, you can capture what are called annotation views. And these can be your traditional views like front, top, and right, or you can also create your own views as you need to for things like details, sections, and break views. So what we're going to do is activate some of these views to create our dimensions on. While the front view is activated, we'll then go ahead and start to add dimensions using a traditional tool in SolidWorks called the Dim Expert. Here you'll see with the Dim Expert we can add any sort of location dimensions, such as this horizontal position and this overall width here, or size dimensions if I want to add any sort of hole information. And you'll see that all of that dimensional information is being captured directly on the front view. Once I'm happy with my dimensions, I can then store that as a captured 3D view here, and that will have all of the information needed to pass this information downstream into my technical data packages. We'll add a couple other dimensions to this top view. So for instance, some size dimensions for these holes, and maybe a positional location of the hole as well. And we've got exactly what we need for our top view there. Any sort of additional information you want to add that you would traditionally represent on a 2D print, such as datums, geometric tolerances, and even pattern instances, can be captured directly on the 3D model. You can even put in additional information such as surface finishes and weld symbols if you're dealing with more complex machining operations. We can even take this a step further and add things like section views, model break views for very long parts, and explode views for assemblies. But essentially, what you'll be doing is adding dimensions and capturing your 3D views as you go. That's a quick overview of how to create views and dimensions from within SolidWorks that we can then use downstream in MBD. So as you can see, it's very easy to create these dimensions, simple to learn it, easy to use it, and it's also using existing tools like DimExpert to allow you to generate that content directly inside your 3D model. What I want to take a look at next is some of the export capability once you've got all the dimensions created and how that information gets relayed downstream. So let's take a look in SolidWorks. So here we have a completed gear plate part file inside SolidWorks, and as you can see, it has all of my dimensional information for manufacturing that part. So we have our top view, our front view, and they all have the associated dimensions for manufacturing this downstream embedded in the 3D model, just as I was creating before. Once I've got that content created, I can then publish that out to industry standard formats. So as you can see, I can publish that out to a 3D PDF, an e-drawing, or even a STEP 242 file, which is a relatively new file format for translating neutral files into a widely accepted format that also contains all of the dimensional information and product manufacturing instructions embedded in the 3D file itself. As I publish this out, you can see it's a very simple one-click process, and I can then pick what dimensional views that I want to put into that PDF, and also pick a template that I'd like to work with that has all of my header information and relevant property information similar to a traditional drawing title block. I can even take and attach a file if I wanted to embed a step file or a parent SolidWorks file directly in that PDF. So we just took a look at what you can export and how the export functionality works inside of MBD. As you can see, it's very easy to publish this stuff out, and once you have a standard setup, you can publish out any sort of widely accepted format downstream for manufacturing. So whether it be a step file or a PDF or even an e-drawing, you can generate that content very quickly and easily. So next, let's take a look at how those standards are developed and how templates are set up inside of MBD. Inside of MBD, there's a full template editor built in so that you can adjust anything about how the deliverables look and feel on the manufacturing side. So here you can see that we have a header as well as any sort of relevant information and title block info that's going to be captured as part of this part. So when I generate this part, you'll see that we have our standard viewport to work with, as well as our published views navigator down here, and we can also adjust and customize this to meet our company's needs. So whatever information you need downstream, whether it be manufacturing notes, materials required, dates, revisions, all of that information is going to be captured inside of the published content rather than having to capture that as a secondary file on a 2D drawing. So that was just a quick glimpse of how the standards and templates are developed and how you can create a standardized template that ensures you're using the same repeatable data every time downstream. So we just took a look at how views and dimensions are created and how easily you can create DimExpert dimensions directly on your 3D models. Then we took a look at some of the export capabilities and the kind of content that you can publish downstream for use in the manufacturing side. We also took a look at the standards and templates and how you can develop a quick little industry standard template for yourself. So that's been a quick overview of MBD. As you can see, it's a very cost-saving tool because it allows you to reduce the need to create 2D drawings and maintain all of that. So if the drawing is out of date, that helps you kind of reduce the amount of scrap and rework, as well as the amount of procurement costs that you have of generating out those drawings. It's also time-saving because you can generate out a 3D model that's accepted by a supplier and also cuts down on the amount of engineering time required to generate those 2D drawings, as well as maintain changes on those 2D drawings. Quality improvement is also improved because you're reducing the amount of model to drawing discrepancies and ensuring the communication between the two is seamless. And also, it conforms to any sort of standards you need downstream. MIL Standard 31000A was developed in order to actually create these MBD documents as well as be accepted from the DoD as a technical data package. And the ASME standards of 1441 are also developed in order to take this into consideration. So that's been a quick little overview of SolidWorks Mbd. If you have any more questions or want to find out more about SolidWorks Mbd, please feel free to reach out to us on trimech.com. Thank you for watching.